Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. Today on the podcast we're talking about PG Event Serve, and to help me do that I've invited Paul Ramsey on the show. So Paul Ramsey has been on the podcast a bunch of times before. There'll be links to all of the episodes he's participated in the show notes of this episode today, so we won't spend a great deal of time on introductions. So you might be wondering what PG Event Serve is. Well, it's a PostgreSQL only event server in Go. It does one thing and one thing only. It takes events generated by the PostgreSQL notify command and passes the payload along to a waiting WebSocket client. And it might just be the most useful small thing Paul has ever written. Hey Paul, welcome back to the podcast. Now you've been on here a bunch of times, so for the listeners, if they haven't heard you already, I'll put a bunch of links in the show notes of this episode so they can listen to all the great stuff we've talked about before and interesting things you have to say. But let's pretend for a second I've been living under a rock and I'm brand new to the geospatial world. I have no idea who you are. Would you mind just introducing yourself briefly to the listeners, please?
Sure. I am a developer of the PostGIS spatial database, and thus someone who knows something about a little bit about geospatial, a little bit about databases, a little bit about the uses people put those technologies to.
Yeah, I like that. Someone who knows a little bit. I like that.
A little bit about everything. Yes, I
Yeah.
am the ultimate dangerous man.
Yes. Okay, and you've developed something else. It's something called PG Event Serve. Without going into heaps of detail, heaps of background around PostGIS, I'm assuming people have an understanding of what that is now. If not, again, you've been on the podcast before. There'll be a link to that in the show notes. So let's dive in. What is PG Event Serve? What does it do?
PG Event Serve watches for listen/notify events coming out of the Postgres database and converts those events, which are something native database world, into events on WebSockets, which are native to the web development world. And to give that explanation, I have, for most users, explained absolutely nothing.
Right.
Because
Okay, what problem are we trying to solve here? Maybe we should
Yeah.
start there.
I think that's a good place to start. The problem we're trying to solve is the problem, and this is a problem which is more native to maps than it is non-mappy interfaces. It's a problem that information in a database can change, and the people looking at that information might have gain a great deal of utility out of being able to see that change, and pushing that information out from the database to the people with user interfaces can be a fiddly thing. It turns out that all the facilities to do that trick exist in the database and exist in the web technology world, and there has been a gap in between them that needed to be filled, and that's what PG Event Serve does. So on the database side, there's this idea of listen/notify. It's a Postgres-only feature. It doesn't exist in SQL Server or Oracle, but what it lets you do is, if you are a database client, and that could be really any software which connects directly to the database, you can say, I would like to listen to channel 5. And it's not 5, it's actually a text string, so it could be channel Daniel or channel Sailboat. But I want to listen to channel Sailboat. And that database client will, in addition to the other things it's doing, have a listen set on channel Sailboat. Any other database client can then say, or the database itself can then say, I have a notification for channel Sailboat. And at that point, every client who's listening on channel Sailboat will get that notification. It is asynchronous, which is to say it happens, actually no, it's synchronous. It happens immediately. The magic comes when you start to hook up things that happen in the database to this notification procedure. So the easiest thing in the world is to add a trigger to a table that fires every time a row in the table is updated or inserted or deleted. So it's like the table's thing you care about. Anytime something changes, update, insert, delete, a notification gets thrown. Every client watching that channel then gets an update that the table's changed.
Yeah, I just want to clarify a couple of things here.
Yeah.
The firstly, the client. Are we talking about like a QJS client, for example? Or when you say client, what do you mean?
Yeah, it's good to clarify what I mean by database client, because pretty much anything that looks at data, anything you see on your screen is at some remove a database client. But I mean this in a fairly specific way. I mean a piece of software which has attached to the database using the database's specific communication protocol and connection port. Very, very technical. QGIS, it turns out, is a Postgres client in that very narrow sense in that it literally connects to the database directly using the Postgres connection protocol. If you work with Postgres yourself, you might have used like the PSQL terminal monitor. It too is a native connection. So it's quote unquote a database client. You'll note I've not said like Chrome or Firefox or web anything, because even though those interfaces, those web interfaces, very, very frequently, almost always show data which is residing in a database, they do never connect directly to the database. They connect to a web server, and the software that's running inside that web server may or may not at some point connect directly to the database and ask questions of it. So there's always there's this thing that sits in between a web client and the database. And usually the thing that sits in between the web client and database just does stuff like ask for a file, get a file back. We want to do something different than that. In order to get a web client to update when the database table changes, we need to somehow take that signal, that notify signal, which is coming out of the database, and convert it from something which standard database clients can hear to something which web clients can hear. And that's what PG Event Serve does. It just sits in between. And so you tell PG Event Serve as a web client, hey, I'm interested in Channel Sailboat. PG Event Serve sets up a native database connection on its side to the database and says, hey, database, I am interested in Channel Sailboat. When the notification comes up, PG Event Serve gets it on the database side, flips it over, and sends it on to the website. And it does that using a technology called WebSockets. Unlike most web tech, where the client is in control and says, I want this file, give me this file. I'm interested in stuff at this URL, and the web server gives it back. With WebSockets, it's possible for the server to be in control and to say, hey, web client, here's something new. And that's what happens. Now, for a banking app, or really almost like any sort of form-based standard enterprise app, like the amount of data that someone's looking at any given time is practically none. So the odds that there's any utility to being able to tell the clients, hey, there's something has changed, you need to update yourself, is relatively low. But think about what a web map shows. Like it's not infrequent for a given web map panel to visually be showing the end user absolutely every single record in a table. So if there's more than one user and they're changing things, they're almost always changing something that's visible within the frame of the other users. And it makes quite a bit of sense, again, depending on the app needs, for that change to propagate immediately and for every user to see it when it happens.
You're right that this makes a lot of sense, especially if people are making decisions based on what they're seeing in the frame of the map. Can you talk to me or just explain briefly how this happens today? Because we're used to maps updating. Could you explain that process just before we dive into listen, notify, and these triggers that you talked about in just a little bit more detail?
Right now, if you see a map self-updating, there's a strong likelihood that it's polling. I mean, there's nothing wrong with that. But that means that the control is still held by the client. So it's getting updates at whatever its polling rate is. If it is in fact a truly asynchronous update-based system, it may have some quite complex middleware in the middle that's handling the WebSockets and maintaining information about the state of the system in the middleware, which is, again, like a perfectly reasonable way to solve the problem. And for problems of certain scale, of tens of thousands of moving objects, might be the only way to solve the problem. The nice thing about centralizing the model in the database and saying, my understanding of the state of the system is entirely contained in the database tables, is that it is a modeling system that still allows every single piece of database connective software to participate in it. It's not something bespoke. It is something which still operates by the rules of SQL. And in fact, my favorite trick in demonstrating PG Event Serve to people is to get them to look at either a web map or ideally both a web map and like a QGIS service. And for me to say 1, 2, 3, to write a little piece of SQL, which updates the map object they're looking at and show it to them in like just the SQL terminal monitor and say 1, 2, 3, boom, magic, hit return on the SQL. Database table changes, all their maps immediately update. And that was just the result of writing SQL. I didn't have to like deal with any sort of special magic middleware piece. I could just use SQL to do the updates. And so it means that any client which can talk directly to the PostGIS tables can participate in this live data. That's kind of how I differentiate it. I've gone way off base on your actual question, which is unfortunate.
No, you're doing a great job. But so I understand this like this. So there's this functionality in the database called listen notify. We can attach triggers to that.
Mhm.
So something happens to the database, an action takes place, we add something, we delete something, we update something. If I'm listening to this functionality, I get a notification. This is great if I am a QGIS client, for example, that's connected directly to the database. You've built this thing called PG Event Serve, which sits on top of the database and adds the same functionality to something called WebSockets, which means a web client also can be updated. You can force the update of the map through this PG Event Serve, if I'm understanding you correctly.
That's absolutely correct. And even better, depending on what your system is built for, even better, the notification can be a lot more precise than just, hey, the table's changed. It can be literally, hey, this object has moved and here's its new coordinates. So it's possible for the map to update itself in a very granular way. It does not just have to go back and pull the whole table again and redraw the whole thing. It can, in fact, move objects one at a time if the notification is explicit about what's changed.
Okay, so what kind of clients will react to this? Like what kind of clients have this functionality? You might guess from the question that I am not a front-end developer. But if I'm using something like Leaflet, just
Yeah.
as an example, will this just work?
There's going to be some plumbing because there's not like an extant standard that you can just say, this is a moving object layer, go. You're going to have to write a little bit of JavaScript to connect to the WebSocket, and you're going to have to plumb between the events that are coming off that WebSocket and your layer of things that are moving. The good news is that the plumbing is really quite small. And also you can subsume a lot of the complexity into the database side because the listen notify payload, it's just a string. It's just a hunk of text. So it's really quite easy to build a JSON payload inside the database and then fire that out through this piping. So you end up with something a little payload, which is really quite web native. Even though you compose it in the database, it shows up in the client. You can just say, oh, this is JSON. Great. I'll parse that and then act based on it. You can see how narrow the amount of code is by looking at the PG events or code base itself, because it ships with a bunch of examples, including live examples of things that move. And you can see how small or large you can make the system inside the client. But yeah, it does involve some JavaScript. It's not point and shoot. One thing I learned after publishing, I can't remember what blog, some kind of blog post. Someone was nice enough to pipe up and say, "Hey, did you know? I mean, you think this is really cool and specific to like web tech, but in fact, QGIS already does some of this. So there are hiding in the bowels of QGIS some facilities to do live response to listen notify as well, which is really awesome because in all my demonstrations, I just ended up having to manually force QGIS to redraw to see that things had changed. Whereas, in fact, you can tell it, oh, watch for notifications and redraw yourself, which is kind of mind-blowingly awesome. It means that all your clients can be completely live.
That is really cool. Like if somebody's just been looking, dragged in a bunch of data, looking at it, but it's changing in real time or near real time, and they're doing an analysis of that. That's great to be able to say, hey, you need to update this again. How difficult is it to install PG Event Serve? What does it take?
It takes almost nothing. PG Event Serve is written in Go, which ordinarily would be like, who cares? But Go is a surprisingly multi-platform language, and it also is a language where it's very easy to build completely self-contained binaries. So to run PG Event Serve, you go to the PG Event Serve page on GitHub, or you just type PG_Event Serve in Google, and that'll end up taking you there. You can download builds for Linux or Mac OS or Windows. And inside those zip packages will be a single executable, which you just run. You set an environment variable to tell it which database to connect to, and you run it. That's it.
Oh.
If you're into containers, there's also a container.
I'm not. So the idea of just running something sounds amazing. What does it require in terms of the data model? Do I need special timestamps? Is it looking for a specific field? What's happening in there?
Because the notify payload is just a hunk of text, there is no preset data model. It will take the hunk of text that you generate in the database and hand it to the web client that's watching that channel. So it's really contingent on you as the app designer to format that hunk of text in the way that's most useful to your end client. Almost always that's going to end up being JSON, but it could be anything you want.
Given that this is a geospatial podcast, this might be the dumbest question ever, but is this only for spatial events?
No. In fact, one of the demonstrations that ships with it is like a little chat. You can write your own Postgres chatbot. It doesn't seem, it is totally pointless, but it does make not a bad example.
Okay. So it sounds really cool. When I think of about use cases, I think about alerting movement in and out of geofences as an example.
Mhm.
Just the general, hey, this thing has updated. What else can you come up with in terms of use cases, just to help people start thinking about what they could do with this?
Well, you kind of took them all away. Um, yeah, so map update is one. I think it's probably actually less interesting at scale than the geofences. The nice thing about geofences is, again, you can program them entirely inside the database, which is great. Every time they end up being triggers inside the database. Again, no third-party software required to have a geo alerting setup. I think the real thing is any kind of thresholding. So geofencing is a kind of thresholding. It's just a spatial thresholding, right? This thing is moved into the spatial area. But it's a database, right? So it can work on any kind of thresholding you want. An obvious one would be to set limits on a measurement, or have like a linear model which is fitting to a time series, and throw an alert when things become residuals outside of a expected value range. You can do an awful lot of statistical analysis right inside of Postgres, either using PLR if you're like a complete statistical super person. Even if you're not a statistical super person, Postgres actually ships with built into it, like these are just the standard functions, linear regression. So you can do least squares analyses right inside your database and get analyses of the residuals. So you can look and say, okay, the latest value is outside of my
Wow,
expected value based on the last 3 hours. Therefore, I'm going to throw up an event and something will happen.
that is really cool.
Yeah.
What about, can you maybe give us a little bit of an understanding of how flexible those triggers can be? So I don't know, could I use something like this to look at changes over time? Could I aggregate changes and say, look, this has been the net movement over an hour, or something like that?
Yes. I mean, the triggers themselves are like 3 lines of code. All they say is, for a given event, and a database, there's really only like four. Anyways, insert, update, delete, 3. For a given event, run this function. And that's where it gets incredibly huge, because this function can be of any length, can call any number of SQL commands, can have whole bunches of places where it maintains its state internally. Like, it's not just one SQL call, it's as many as you want to write. There is a default language, PLPGSQL, you can write functions in, but you can also write them in third-party languages. You can write your functions in Python and take advantage of any Python module that happens to be inside your runtime. So you can, in fact, do like machine learning stuff inside your functions.
Wow.
The answer is like anything you can program, you can attach to a trigger and have run when an event occurs inside the database. Anything.
Wow. Wow. Okay. So I'm sure there's a bunch of people that are much more skilled at this than I am, that have way better ideas than I do. So I'm going to let them figure it out from here in terms of what's possible. I want to sort of jump back into this idea of real-time updates or synchronous data, maybe. Could you tell us what were people doing before, and what does this replace? So you mentioned this idea of polling before. I think we're all pretty used to the idea of, we pan the map, we stream data in. When is this the right answer, and when is this alerting the right answer? If you had to draw a bit of a line in the sand.
I would say alerting is the right answer when it truly is a real-time problem, because you can get a long way with polling, and it's not like 5-minute old data is bad. It's like, most of the time, 5-minute old data is like incredibly good and far better than anyone ever expected before. There's a fetishism around true real-timeness, which I admit to pandering to with this tool set. You can get a long way with just polling. You still probably maybe should think about having events come live off your database, because it's such a lovely system that ties in computation with model state, and taking as much advantage of it as you can before you start building external model state is really a good idea, just from like a programming efficiency point of view. There's this weird like bifurcation between when is real time needed and when it is not. And you can kind of see it in like things like the Uber app, or really anything where you've got like a moving car or something, where like most of the time people's expectation and requirement for real time data is way lower than they think. It's like, yeah, real time. I want that to be real time. Definitely deliver that. And the reality is, you give them 5-minute data, and it's not going to change their decision process to have 2-second data. And yet things flip over when you start to look at things like cars moving on phones, where all of a sudden, not only do you want to have this illusion of seeing exactly where the vehicle is, the actual data the vehicle is producing, like the GPS stream, is less accurate than the user expects it to be because, like GPS tracks are like plus or minus 5 meters, and the data is literally only coming in from the vehicle every 30 seconds. And yet people want to see the vehicle kind of smoothly transition along the road network and turn left at the corner. Whereas if you just do the GPS track, like the vehicle would be hopping across blocks and driving through houses. There's this strange requirement at the visualization level where people just end up going deeper and deeper and deeper to the point where, at some point they actually want to look at data which doesn't exist. They want to look at things that are at a higher resolution than the most real-time data they can get at is. So it's a push and pull, I think, between the people who are consuming the real-time data and the people who are actually like working with it.
I realize, of course, at the end of the day, it's the people that are building these systems on top of tools like this that make the decisions. They decide what's important to them. But I really appreciate your perspective there. And I love that example of like the GPS locations of cars. I think this is great. Like in that example, at least in my mind, real time is not an advantage. I would rather have a smooth transition, I think you called it,
Mhm.
as opposed to like cars jumping in and out of like different lanes and through houses and moving around in real time.
Yeah.
That's not helpful. I think something at a lower resolution would be much more helpful. My last question here for you, or one of my last questions is this a cool hobby project, or is this, could I take this today and use it in a production environment?
You could. It's a wonderfully small project. It is the most useful tiny thing I think I've ever written. So I haven't seen any breakages on it from users. I've shoved it through very high load testing, and it found some places where I made mistakes and got rid of them. And now it doesn't break. And what it provides is so narrow and simple that the main thing where people might not be using it in production is it does depend on being able to maintain the state of your system inside the database model. And it is possible in the geospatial world to have a large enough corpus of continuously moving things that maintaining the model state inside the database is actually just too much transactional churn for the database. Like you have 10,000 all simultaneously moving objects spitting back changes every 5 seconds. That's a large number of transactions per second. And you might be getting to the point where the database isn't the best place to have that model running, particularly if you're asking questions of it, fire off alerts when things get close to each other. But for lots and lots and lots of practical purposes, it seems like, put it into production. It's simple. It doesn't break. I hear far more complaints about my tile service than I do about this thing.
Okay. Well, I guess that's a really good sign that you hear more complaints about your other pieces of work than you do about this one.
which I should bracket by saying that the tile service is 4 years older and and mostly asks questions to the database. It's just, I don't know. It's just it has to do with the underlying complexity of what you want the system to do. And if it's a very very small tools which do very constrained things, you can kind of reason about and feel confident about in ways that you can't with systems that have fewer constraints. So the tile service is a more complex system. So it's not as perfect as the event server is.
Well, I'm sure if you built it, I'm sure it's good enough, if nothing else. Where can people go if they want to check this out?
If you type PG_event serve into Google, you will find the GitHub page, which has a lovely explanatory text right up front, which will tell you what you can download. Again, it's the binaries of the download. The documentation explains how to set it up and how to run the examples. You should be able to get something up and running real fast. The main sort of prerequisite is, it's web tech, so you've got to know enough about web tech to write your own web map.
So this is where we can find the tool that you've built, PG Event Serve.
Mm-hmm.
There'll be people listening to this that would like to reach out to you, hear more from you. Where could they go to do that?
If you go to cleverelephant.ca, that's my contact information, and also blogs I publish about a number of topics, including this kind of stuff. I also work for Crunchy Data Solutions, which is a Postgres support company. They have a blog. A lot of my content on things like event serve and tile serve and other things you can do with Postgres resides there. So if you go to the Crunchy Data blog and type in my name as the author, you'll see some pretty cool talks. Oh, the other one, which is great, is Postgres Day. We've had 4 of them now, online Postgres Day, and all the videos are published online on YouTube. So if you go to the Crunchy Data video channel, you can find the Postgres Day talks, including for this last year, a specific talk on PG Event Serve, which might be the best entry point to the topic.
I'm really pleased you mentioned that. I've actually watched that on YouTube myself, and it was brilliant. I will definitely include a link to that in the show notes. Right, Paul, thank you very much. Thanks for showing up again, giving us your time and teaching us a lot as well about the tool that you've built and about PostGIS, GIS in general. I really appreciate it. Yeah, cheers.
Thanks for having me.
Thank you very much for listening all the way to the end. I really hope you enjoyed that episode with Paul about PG Event Serve. As always, there'll be links in the show notes. Check them out. I'll link to the PG Event Serve on GitHub, and of course the demonstration of PG Event Serve in action on YouTube. And as I mentioned in the introduction, Paul has been on the podcast a bunch of times before, so if you want to hear more from him, which would be a great idea, there'll be links to those episodes in the show notes of this episode. If you want to reach out to me for whatever reason, you'll find contact information at mapscaping.com. I'd love to hear from you. Okay, that's it for me. See you again next week. Bye.